everyone. In this experiment, I will use a spring with a constant K. I will use a puck. I will use an airtable and a paper for measurements. Also, I have a wooden block for giving a slope to the air puck, air table. I will compress the spring with a puck with different compression rates. Then I will measure how height is the puck use. Then I use the conservation of spring potential energy to gravitational potential energy. We assume that there is no friction in the table, and we will try to observe the conservation of this energy.
The experiment goes as following. I compress the spring with different compression amounts, then I release the spring so that the potential energy of the spring is transferred to the puck, which eventually becomes the gravitational potential energy. So I measured the gravitational potential energy and then do the calculations. In the data part, I tabulate the collect data and then plot them. The first plot shows us a relation between the maximum height of the puck and the compression amount of the spring. The reason that the parabolic relation is because of the equation that's shown in the screen. As the compression amount goes linearly, the maximum height goes quadratically. In order to obtain the k from the plots, we need to make a linear plot, so that I made the second plot. In the second plot, we can see the linear line because the relation with the h is plotted with the x square, which is the square of the compression amount. In that way, we can use the equation that's shown in the screen to figure out what is k from the slope of the plot. There are some measurement errors which can obviously cause from the human eye and the assumption of the frictionless surface. Basically, we have air resistance and we have friction, even though we try to minimize it. Although there are some errors like that, the percentage of the error is a kind of 10%, which is good for our estimation.